Today's show is sponsored by Cloud Academy. Listen up, y'all. This is a great offer. With everyone using the same cloud platforms, winning and losing comes down to having the best talent to build products better and faster. Cloud Academy is the training platform of choice for Fortune 500 companies and thousands of tech professionals around the world. Thousands of video courses, learning paths, practical hands-on labs in real-world cloud environments, Cloud Academy has tools designed to help teams assess, build, and validate critical cloud skills. Most importantly, Cloud Academy stays agile, challenging you with new content, labs, and tons of features that ensure your skills stay relevant and everyone can level up. They cover everything from cloud certifications to DevOps to security to programming languages. You can get started now at cloudacademy.com. For a limited time, Cloudcast listeners can lock in 50% off the monthly price for life. Just put in the coupon code CLOUDCAST at checkout. It's a great way to pursue certifications or just build cloud expertise. Again, that's cloudacademy.com and use the coupon code CLOUDCAST to lock in 50% off the monthly price.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We are coming to you live from the massive Cloudcast studios here in Raleigh, North Carolina. As we continue to move through November 2020 feels a little bit like the maybe 100th week of March 2020, but we continue to plod along. There's a little bit of good news. It looks like a second vaccine is starting to find some efficacy out there in the early trials. Hopefully they continue to make progress on that, and maybe we'll get back to some sort of normal here in 2021. But hope everybody's doing okay and starting to get ready for some of the holiday season. A little bit of cloud news of the week. This week is both KubeCon and Cloud Native Con, so a lot of folks are busy with that. A lot of announcements coming out. We will be digging into that next week, and the following week we're going to do sort of a state of Kubernetes show. But we're going to hold off on any sort of kind of analysis of Cloud Native Con this week with our cloud news of the week. But there was a couple of things of note we're going to hit on, not any real big things, but a couple of things that are interesting. Cisco bought another Kubernetes startup. This is the second one they've bought here in the last few months. This time they bought Bonsai Cloud. Quite honestly, I can't quite figure out why Cisco keeps doing this. You know, they've tried to sort of get in the cloud game. They've sort of tried to get up above the networking space. They've done okay with some of their SaaS acquisitions, but don't seem to necessarily have a great track record when they sort of buy these software infrastructure companies and then try and layer it on their networking space. But they did buy Bonsai Cloud, and it kind of complements their port shift buy from a few months ago. Second was Palo Alto Networks, who has been on a buying spree of the last couple of years. A lot of interesting technologies, security technologies for the most part. Acquired Expanse for $670 million. Expanse, about an 8-year-old startup who focused on sort of mapping out the internet, trends and traffic on the internet, and looking for global threats and how to resolve those. And then finally, PingCap, the company behind TIDB, raised a D round D of $270 million. So nice big healthy round for PingCap. Not a company we've ever had on the show. Maybe something we need to dig into. If they're hitting a round of $270 million, it shows that they're continue to expand and grow and have enough in sales to be able to support this sort of big round of funding. So congratulations to the folks at PingCap. And with that, we're going to wrap it up. Kind of a short cloud news of the week, kind of short and sweet. We are going to talk a little bit about some new things around cloud native networking and around cloud native security and all that I think you're going to really like. Every time we dive into some of those topics, I know there is a really hardcore group of you that really likes to dig into that. So we're going to dig into both Cilium and eBPF right after the break. Today's show is sponsored by Fauna. Fauna is the data API for modern applications. As application architectures evolve to embrace cloud APIs and microservices, you need a database that is always correct, always fast, and always secure. But you don't want to spend valuable time managing your database. Fauna modernizes your OLTP infrastructure by providing a 100% operations-free database without compromising on the capabilities needed for building industrial-grade enterprise applications. Whether you're building new microservices or augmenting existing services applications, FaunaDB lets you simplify code, reduce costs, and ship faster. Fauna is a Jepsen-verified, globally distributed OLTP database delivered as an API that works with the programming language of your choice. To learn more, visit fauna.com/cloudcast to try it for free. That's fauna.com/cloudcast to learn more and try it for free. Today's show is sponsored by Datadog, a cloud-scale monitoring platform that unifies metrics, logs, and traces from technologies like Istio, AppMesh, and Envoy. Plus, Datadog's Service Map automatically plots out the dependencies in your microservices architectures for seamless, context-rich troubleshooting. With rich visualizations, algorithmic alerting, and more than 250 vendor-supported integrations, Datadog allows you to monitor your distributed applications in real time. Start a free 14-day trial today by visiting datadog.com/cloudcast, and Datadog will send you a great free t-shirt. That's datadog.com/cloudcast. And we're back. And folks, there's always a little bit of a sweet spot in my heart, kind of a warm place in my heart for networking. Anytime, having worked in the networking industry for years and years before I kind of got into cloud, I'm always interested in how folks move packets around, how they make them safe, how they make sure that they can get from place to place. And quite honestly, I've reached a point with my networking skills where networking has changed so much that, my old CCIE is sort of irrelevant at this point. So it's always good for me to go back and talk to the folks who are really changing networking, really reshaping it, whether it's new protocols, new architectures, new things that are making it possible for us to get packets around the world, around the cloud, and so forth. So very excited today to introduce somebody who we've been following for a while, but he's starting a new company. So excited to have Dan Wendlandt, who is CEO and co-founder of Isovalent. Dan, welcome to the show.
Thanks, Brian. I appreciate you having me.
We've been sort of, as outsiders of the industry, following some of the things that you've done in the past. You were influential in starting Nicira, the technology behind kind of really revolutionizing SDN, starting SDN. You were heavily involved with software-defined networking when you guys were acquired by VMware. But for folks who may not be familiar with your work or just not familiar with you, give us a little bit of your background and then what kind of ultimately got you to starting Isovalent.
Yeah, sure. Yeah, so I was one of the first employees at a company called Nicira. I was employee number 5, I think. And, basically Nicira was the company that built Open vSwitch, if you're familiar with that. And kind of drove a lot of the software-defined networking movement inside of Linux.
Right. And
kind of the core theory was, networking used to be about boxes and humans typing at keyboards and boxes. And, what we saw with Nicira was this trend toward, hey, you're trying to automate everything. A VM might be able to be started in a couple minutes, but if the network to put that VM to be able to talk to other people needs to be plumbed by a human, that's going to be a big problem. And so we kind of, I think, realized very early at Nicira that networks wanted to be programmable, and we built Open vSwitch as this kind of programmable layer inside of Linux. And then as part of that, one of our first customers was actually Rackspace. And Rackspace went to us and said, hey, we're starting this OpenStack thing. We're going to use Nicira. So, can we work with you to make sure that OpenStack networking is great? And so as part of that, I created and led the OpenStack networking project, originally called Quantum, then renamed to Neutron. So, drove a lot of that up through, it was mainly focused in the Linux space. And then what obviously happened was most of the world at that time was still VMware hypervisors. And, right. So we were partnering and trying to figure out work with VMware of how can we get Open vSwitch inside of VMware. And the short answer was, well, they can buy us.
Yeah.
And so that's what happened. And, that was I think it was a great example of, an exit that was successful for the startup and I think really successful for the acquirer.
Yep. Yeah, absolutely.
Not always the case.
Right, exactly.
We're still very proud of that. And I think proud of what we built there and proud of what it's become. At the same time, I think we saw this, if you look at what Open vSwitch did, if you look at what IP tables did, which is what my co-founder, Thomas Graf, who's a longtime leader in the upstream Linux community, worked on for years, it was taking that kind of traditional model of networking. We still dealt with packets, right? We still looked at IPs and ports. We still thought about ACL lists and tables and firewalls and virtual segments and virtual routers instead of physical ones. We were still very much kind of taking that traditional networking model and implementing it in software. And Martin Casado, who's the founder of Nicira and is now our investor at Andreessen Horowitz, he and I really, I think, always shared this vision that once you got networking into software, you could do so much more than just replicate what the hardware was doing. And the key thing that was missing there was the ability to make that networking data plane truly programmable, not just programmable in the sense of being able to match on packet headers, but really being able to do whatever logic and algorithms the app requires. And that's where eBPF, which is the core technology we build and maintain at Wendlandt, and is the kind of the fundamental building block of Cilium, comes into play.
Yeah, and I want to dive into both eBPF and Cilium. I want to ask a little bit one higher level question before we dive into them, though. Yeah. So, I mentioned in the beginning, my networking background goes back to the days when people used to get Cisco CCIEs, and you were kind of tied to that operating system. It could be iOS or Juno S or whatever it was. The last 7-8 years has really been all these changes in Linux-based networking, right? And that shifts, where processing happens. It moves it closer to the application, but it 100%. It makes it programmable. Like, for somebody who comes from sort of the more traditional networking background, like, talk about why has Linux become really the new place for all these networking changes to happen, as opposed to sort of somewhere else it could have happened. What's it been about Linux and this community of doing it in the open source that's changed things?
Well, yeah, no, I mean, I think you've hit it on the head. I think that is like kind of the macro trend that's happening here, right? Is that you've got a whole set of vendors, like, you all know the names. I don't need to call them out individually, but, who built all of this load balancing intelligence into a hardware box, and security intelligence into a hardware box, and network tap and observability intelligence into a hardware box. And the reality is, like, those boxes really don't make sense for how people are building and deploying apps anymore. Even if you were able to program those boxes, it doesn't matter, because, people are building these hyper distributed apps. So you can't send all of that traffic through a single box. Secondly, you have people running on platforms like Kubernetes. So suddenly, you have multiple containers that are talking even within a single VM. None of that traffic is even visible to the box.
Right.
And then finally, most of our customers are, already or soon to be running in a public cloud. And you don't even know what boxes are underneath there. The one thing you do have consistently, whether you're on-prem, whether you're in public cloud A or public cloud B, is that Linux layer. And so I think the ultimate trend is, if people want consistent abstractions for how they handle everything around connectivity, load balancing, security policies, observability, both for troubleshooting and for the SecOps teams, how do you do incident investigation, things like that, you need kind of Linux is that one layer that that is consistent and can apply that and sees all of the traffic, even in a Kubernetes environment.
Yeah. No, that makes total sense. It's, you kind of have to look at it in the sort of historical sense of, it used to be boxes. It became, like you said, it was Open vSwitch and other things, and now it's just kind of extending to be closer to those applications and that software. Let's dive into these two topics we mentioned, eBPF and Cilium. Give folks kind of a high level, where do they kind of fit together? What do they do? Because as I start digging into it, it's a packet level filter, so there's some security aspects to it. There's visibility aspects. There's mesh between cluster. Like, what do these two things do? Why do people need to care about them from a next generation networking, next generation clustering perspective?
Sure. Yeah. So we just talked about how Linux is the strategic control point that exists everywhere for networking these days. And yet, if you look at the Linux functions that were built into the kernel and have been there for 20 years, you've got things like IP tables and, IPVS, these types of things. It's very static functionality, right? Whoever thought about what kind of networking you might want to do a long time ago built it in, and it's built into the kernel. And what eBPF unlocks is the ability to make the kernel fully programmable. That means that we can write whatever networking, load balancing, observability, security, logic we want, and safely load it into the kernel in a way that runs with the exact native performance of a kernel. And in fact, in a lot of times can outperform those traditional mechanisms, because we're tailoring the algorithms directly, for example, to what Kubernetes needs for load balancing, but doesn't have all of the downsides of using kernel modules. They can't, kernel modules might crash your kernel, might hang your kernel, drive your security team nuts. eBPF runs that logic in a sandbox where it can only access the data it should and can't crash your kernel. So what that means is that eBPF is kind of this raw engine, very low level thing. Like you're literally writing kernel code, but it's a raw engine for kind of injecting additional logic into the Linux kernel. And Cilium is the open source project that uses that raw engine to solve all kinds of networking, observability, and security challenges inside of Kubernetes, but gives end users much higher level kind of human abstractions of what to do. So instead of dealing with eBPF and low-level kernel bytecode, you're creating declarative security policies that's, say service A can talk to service B, right? Kind of things, or you're getting that, flow audit logs that your security team can use for incident investigations. Okay. So we're kind of using eBPF as an underlying engine to let us do much better, to do more powerful things than would be possible with the built-in Linux networking, and then using those to solve the challenges that businesses have as they're trying to securely run workloads on top of Kubernetes.
Okay. And let me know if I have this, and I don't know if I have this analogy right, but I'm trying to compare it to things just so I can put in my head. Is Cilium essentially sort of the control plane for this new way of thinking about networking and sort of packet visibility, and eBPF is almost the data plane or the agent that would live there? I mean, is it that sort of relationship, or should we think about it in some other way, how these two interact?
It's a little different from that. Cilium actually is the data plane. Cilium generates BPF. So BPF is like literally the ability to write programs, write code, and load it into the Linux kernel. It's a very generic abstraction. It has nothing to do with networking whatsoever, right? It just happens to be that some of the kernel functionality that you can inject in there can do networking things. Okay. Right? But Netflix uses it 100% for performance visibility, right? Okay. You can use it to inject any kind of networking intelligence. So you can think of it almost as Cilium generates a set of very advanced, very powerful eBPF programs that function as the data plane.
Okay. Yeah, okay. That makes sense. So
Cilium is both the control plane, and it generates eBPF programs that are, it understands the identity of each Kubernetes workload. It says, oh, I know this is, this service running from this team. It should be able to talk to these things. It then builds eBPF programs to very, very efficiently, only allow that connectivity and very efficiently do the load balancing that exactly that workload needs.
Okay, that makes sense. So the two are always going to kind of go hand in hand. Cilium is the thing that, is sort of where programmers would really interface, because it's not as low level as the kernel. It gives you more sort of natural interfaces to work with, and then eBPF goes and kind of does some of the low level work that is ultimately what you want to do.
Thinking about it at that level, Cilium is the human interaction layer.
Yep.
Right. Whereas eBPF is literally it's low-level kernel code that any normal human, would look at and be like, what the heck is going on there?
Right.
Versus, Cilium lets me specify these policies that I can totally, in high-level constructs and all that. So it's really a question of abstraction.
Gotcha. That makes sense. So, you early on, you were kind of laying out where this has been going, and you said, look, this new technology, whether it's Cilium or eBPF, really gets you away from having to think just about packets and kind of pre-programmed way of doing networking. What are some of the immediate kind of missing gaps that this combination now provides that, a year ago, 2 years ago, you really couldn't do, or it was, just incredibly hard to do? What are some of the immediate impacts you're going to see from this?
Yeah, sure. So I think, it was funny because you mentioned right at the outset, it was kind of, I think of networking as moving packets around. And, I think, nowadays we had one of our customers runs a really large online marketplace that we've all used. He made a statement saying networking isn't just about moving bits around efficiently anymore. It's about doing that, but doing that securely and doing that with deep observability. Mm-hmm. And so it's really when you get to those second aspects of security and observability, that I think Cilium really stands out and shines. Let me give a couple examples. So, when people are just standing up Kubernetes, usually their first battle is just, how do I automate the deployment of my cluster? And then how do I onboard my first apps? And usually these aren't the world's most important apps that they're deciding to put on, their very first Kubernetes cluster. But once users kind of get over that hump, then they start dealing with this thing of, okay, I'm trying to move all of my organization's important apps onto my Kubernetes platform because this is our platform of the future. Mm-hmm. And, I, as a owner of a Kubernetes platform, haven't really succeeded until the important things are running on my platform.
Right.
And, that's really where we see a lot of the, enterprises today they're in this transition phase. And what they realize there is this, they've always had as a business requirements around, hey, tenant A must be isolated from tenant B, right? And how did you used to do that? Well, you used to put tenant A on a VLAN and tenant B on a VLAN, and and then a firewall was in between them. But that's really kind of, Kubernetes doesn't align with that model. Kubernetes wants to take workloads, it wants to dynamically spin them up and spin them down and place them on whatever Kubernetes nodes you have capacity on and all of that. So you kind of have this world where Kubernetes doesn't care about the way your traditional network devices apply segmentation.
Yeah.
And so even just getting back to the how do I segment my tenants is a difficult challenge in a Kubernetes world. And so with Cilium, we're able to solve that challenge in a very efficient and elegant and high performance way, because our BPF programs actually understand not just the IP addresses that are being used, but the actual Kubernetes identities that are being used, that are associated with every connection we see going through our eBPF programs. So we can use that to do a identity aware firewall so that, hey, tenant A can talk to other tenant A workloads, tenant B can talk to other tenant B workloads, but they can't talk to each other. And obviously much, much more complicated policies than that. But that's just kind of a good way to get your head wrapped around it.
Yeah, that's really helpful. Do you find that the kind of the typical initial entry point tends to be around Kubernetes these days because it is somewhat different than people were used to, and it can really benefit from these new capabilities?
Yeah, I mean, the typical insertion we see within an enterprise is that they've now deployed Kubernetes, they've been successful, they have to solve a very tactical problem like isolating workloads, or their SecOps team having flow audit and incident investigation capabilities, if you're a bank, or have any kind of compliance requirements, or I need to, bridge and create connectivity across multiple different Kubernetes clusters I'm running. The Kubernetes is a place where a lot of people, have obvious problems and don't have an existing solution to those problems. And so that's typically where we'll insert. But then we often see a pattern that our customers realize that, hey, Cilium is using eBPF. eBPF is a Linux construct, right? It's not a Kubernetes thing. So I've got these, Linux VMs over here that aren't yet running Kubernetes. Can you do Cilium networking for those as well? Can you give me the same, identity-based security and security visibility and even kind of multi-cluster routing and things like that? So we typically will insert first in Kubernetes, but then, often we'll expand into VM-based workloads as well at a customer environment.
Okay, that makes sense. Now, if somebody's listening to this, I could definitely see somebody go, a few months ago, I heard you guys talk about service mesh. Like, are these two things the same? Right? We're talking about kind of stuff going across multiple environments and visibility. Like, are they kind of both, kind of your Istios and your Linkerd? Are they solving similar problems, or do you put, Cilium and eBPF in kind of a different part of the networking stack that maybe is more relevant to certain things?
I think it's a good question, because I think there's both some overlap, but also, a complementary story as well. So if you think about, most customers we have today would think of us as a very advanced, what's called a CNI plugin for Kubernetes.
Yep.
CNI is the mechanism by which kind of Kubernetes has made networking extensible.
Right.
And so you've just stood up Kubernetes. You need to be able to figure out, how do I do security policies that, load balancing, this and that. You typically think like, okay, I'm going to go get a CNI plugin. And Cilium with eBPF is able to be a much better CNI plugin than something built on IP tables or Open vSwitch or something like that. Those technologies that Thomas and I, worked on 10 years ago, kind of a thing. And if you look at the problems that service mesh is looking to tackle, it's in the connectivity, observability, and security space as well. So there's naturally some amount of overlap there. But most people, I think, would kind of say that a service mesh is a large thing to bite off from a complexity perspective and from an application impact perspective.
Right.
So, I think a lot of people we would talk to would say, okay, service mesh is on my radar, but it is way overkill from a complexity and overhead perspective versus the problems I need to solve today. So Cilium, first and foremost, gives people a very simple, efficient path to solve the most immediate problems they have around security, multi-cluster routing, and load balancing. But we also have done a lot of work to make it the best underlying networking layer if you choose to use a service mesh.
Gotcha.
My co-founder, Thomas, had a talk at KubeCon a while back where we talked about how we use eBPF to accelerate getting packets in and out of Envoy. So instead of, Envoy, like your pod sending things, it's broken into a bunch of packets, then it's reassembled and handed to Envoy on that same node, we can actually use eBPF to do really efficient copies there. And so it's an example of how I think eBPF is also a very strategic technology in the service mesh space. And so I think our users would think of it as Cilium is an awesome place to start out the journey because it already solves a lot of the problems I have most immediately and in a way that is very efficient and simple and not complicated.
Right.
But then it's also the right foundational layer to have in place if I decide to go down the service mesh path in the future.
Gotcha.
And I think probably the best data point there is, I don't know if you saw, but Google announced that they have selected Cilium as the new underlying networking layer for all of their GKE offerings. Mm-hmm. And Google is obviously the company that created Istio. So if Google thought that Istio made the Cilium layer irrelevant, they probably wouldn't have spent a bunch of time investing in integrating Cilium into their offering.
Yep.
And so I think what really drew them in was this notion of, okay, GKE users get something amazing out of the box, and they get a great foundation if they decide to leverage service mesh in the future.
Gotcha.
And I think it's safe to say that I think we've got a lot of future tricks up our sleeves to really allow eBPF to let you build the best service mesh. Not that we need to own the entire service mesh, but to be, I think eBPF will be a critical differentiator in that space.
Gotcha. Makes sense. Now, give me a little bit of specifics around Isovalent in terms of, you talked about there's a lot of things that can be done. You guys are delivering excuse me if I kind of butcher this, but essentially a commercial delivery mechanism for Cilium, for eBPF. Is it, you guys are going to, like customers go, cool, I get a bunch of sort of native capabilities and features that you guys have written, you've tested, you've validated. Is that the model in which, they're going to get these eBPF modules, or like how do you come into play to make it simpler for folks?
Sure. So I think the first thing is our fundamental philosophy as a company is that the future of infrastructure is open source. Like you can't make a meaningful change in the infrastructure space without putting absolutely amazing world-class software out there as open source.
Right.
And so our philosophy is that if you look at what a Kubernetes team needs, a Kubernetes platform team needs from Cilium, the absolute best we have out there from a networking and load balancing and security policy enforcement will be open source and will continue to be open source. And I think that's the momentum that we've continued as an open source project has knocked people's socks off. And I think, we plan on continuing, and not just continuing that, but doubling down on it. So most people reach out to us kind of around enterprise support for our hardened distribution around the open source project. That said, we do have additional enterprise offerings on top of it, but it's more about helping those Kubernetes platform teams meet and kind of interact with, for example, their SecOps counterparts within an enterprise. So it's more about the workflows that help the Kubernetes team work with other entities within their enterprise organization for example, making sure the SecOps team can do incident investigations with their traditional tools, like getting this Kubernetes-aware flow data into Splunk and annotating it with the proper things so that the SecOps team gets what they need. Or, for example, allowing individual application teams, giving them RBAC, role-based access control over, hey, I can see the flow data for my namespace, but not for all the other namespaces. So kind of our model from an enterprise value perspective is a lot more around the enterprise workflows that exist at a layer above the Cilium layer, as opposed to like, oh, we're holding back this load balancing algorithm for our commercial thing or something like that.
Gotcha. And that was kind of the follow-up question I want to ask, and you guys are welcome to sort of defer this. We see a lot of companies who, begin life as the experts in an open source project, and it could be, Docker, it could be Mongo, it could be, the folks at Confluence with Kafka and others. And they all have different paths as to how they get to commercialization, which involves both, commercializing the product, how you deliver it, but also like how you continue to interact with the underlying community. Do you guys have a, kind of a model in mind as to, how do you continue to be really good stewards with the open source communities that are under the covers, and then also, how you go to market, and maybe is it always software? Will it be a service? How do you see that playing out?
Yeah. I mean, that is the question, right? When you're starting a company in this space, it's the thing, and you need to have a strategy from the very beginning. And, my personal way of thinking about it is to really think about what you're building as your open source technology is a product, and your commercialization has to be another complementary product.
Okay.
And, because if the way you really differentiate is by kind of withholding, I'll give the database example, like, hey, we're building this open source database and all of our users are really hoping that we implement inner joins. And then we finally do, but we tell them inner joins are a commercial feature.
Yep.
Right. Suddenly it's like, wait a second, you were building the best database, but now you took something that's a database feature and you're holding it back. That's a really hard way to manage a relationship with a community.
Right.
Because it ends up in kind of this zero-sum dynamic of you're either helping the community or helping the company, but you don't create this dynamic. And so everything's like kind of a trade-off there. So I don't think, that's why I kind of mentioned earlier, like our belief is that things that are the Kubernetes networking data plane, like it should all be open source. It's not that this protocol is held back or this or that. You need to say that, but like, hey, if a Kubernetes platform team chooses Cilium and they're in an enterprise, there's a pretty good chance that there's, for example, a SecOps team that they work with, right? And that SecOps team also has these other requirements. And can we sell a complementary product, for example, to that team? That's a much easier way of thinking about things, because everything kind of gets naturally bucketized into who's your user for this. And if your user this is what a Kubernetes platform team needs to successfully do networking in their cluster, that thing's going to be open source. Yep. Right. And if it's something that, hey, this is advanced threat detection for the SecOps person and the platform team would never know whether it exists or not, okay, that's pretty naturally going to be in your proprietary offering.
Right.
And so I think that's kind of our guiding principle, because you need to, I always think of it a bit as like a contract, right? Like if someone's investing in your open source community, they kind of need to know what your contract is to avoid, they're feeling like there's a bait and switch. And I think we've seen other people in this space that have kind of gotten to this point where they feel like they're the leader. And then they suddenly like kind of just turn off the spigot of open source stuff and make everything new proprietary, right? And then that really ticks off your community and causes them to abandon you, and is ultimately, I think, self-defeating.
Right.
So you really need to kind of be very clear about that philosophy and kind of think of it as a contract you have with your open source community.
Yeah, no, I like that. We've all seen really well-run communities and companies that work with that, and then, like you said, we've all seen those examples where you change your mind mid stride and everybody gets thrown off the horse, if you will. So yeah, it's good that you've got the philosophy laid out up front. Listen, Dan, I'm going to wrap it up with that. I know having launched a company, just taken a round of funding. Congratulations to both of those. You're a busy man. I want to be conscious of your time. Thank you so much for everything today. We learned a lot, folks. If you're interested in this space, both Dan and Thomas, his co-founder, have deep expertise in this space. So I think, they are folks and the team they're building can probably help you quite a bit. Any, sort of last good places where folks, if they want to dig into this a little bit more, aside from, the homepage and so forth, other good places folks can engage with the team?
Yeah, so I'd encourage people, who are just looking to learn more. We've got Cilium.io, which is the homepage for the open source project. There's also eBPF.io. We just hosted an amazing eBPF community summit and have a bunch of awesome videos up there. It's everything from end users like Datadog and Capital One talking about how they use Cilium, to people like Netflix and Facebook talking about how they, program their own eBPF programs. So really cool set of content up there. A lot of 15-minute bite-sized videos that you can kind of inhale and learn a lot about this stuff.
Very cool. Very cool. And, as we saw with the Kubernetes community, it starts small. It solves a couple of problems you couldn't do before, and then things start to explode. So, Dan, thank you so much for the time today, folks. We really appreciate it, for myself and for Aaron. With that, we're going to wrap it up. As always, folks, thanks for listening to the show. Thanks for telling a friend. Thanks for rating it on iTunes and all the other places that you listen to the show. And with that, we will talk to you next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.